Some more pH and pOH calculation just to make sure that we understand all sorts of calculations here. The first one here is calculate the pOH of 0.05 molar barium hydroxide. The reason I chose this one is because barium hydroxide has two hydroxide ions. If this was KOH, potassium hydroxide or sodium hydroxide, this would be your concentration of the hydroxide ion. But because this is barium hydroxide, you have two of the hydroxides there, which means that when you have dissociation, the barium hydroxide is going to give you barium ions, and then it will give you two hydroxide ions. So if you're starting with 0.045 molar of barium hydroxide, you will have 0.045 times 2 of the hydroxide ion concentration. So that's the important point over here for doing this calculation. All right, so once you have this 2 over here, this is then 0.09 molar, and then you find the negative log of 0.09, and this will give you a pOH of 1.05. Okay, so that is your answer for this. The important thing here is, of course, a multiplication by 2. If there was something with 3 hydroxides like aluminum hydroxide, then you would multiply it by 3 because you have 3 hydroxides in solution. Okay, next problem then. What is the pH of a solution made by dissolving 0.105 moles of nitric acid in 225 liters of water? And so, sorry, this is milliliters of water. So which means the first thing you have to do is find the concentration. Now this could be given to you in a different way also. Maybe you would be given grams of nitric acid, which means that you will have to convert it to moles. But here I took the little bit of an easy way out. So you have moles already calculated for you, and then 0.225 liters. Make sure that you have your right units. This gives us 4.67 times 10 to the negative 5 molar, and this is nitric acid. So, and we are calculating the pH, so which means we are fine. We have only one hydrogen ion in there, so then take negative log, okay, which will then give you 4.33 as your pH, okay, for this question. All right, the next one. The pH of milk of magnesia, which is magnesium hydroxide, again this is 2 hydroxides here, is 10.52. That's the pH. What is the molarity of the solution? So pOH, okay, is what we'll have to go for, because pH is given to us, which is 10.52. So then the pOH is 14 minus 10.52, because we'll have to take the anti-log, don't forget. Okay, you can do it in different ways. Okay, you can do it in different ways. You can calculate the pOH first, or you can also calculate the hydrogen ion concentration and then use the kW to find the hydroxide ion concentration. Both will work. So I'll show you both, okay, in just a minute. So pH is 14 minus 10.52, which is then 3.48. Okay, so then inverse log of 3.48 is going to give you 3.3 times 10 to the negative 4 molarity. Okay, that's what your concentration of hydroxide ions is. Okay, but yes, there is a but. Okay, because this is not so straightforward. Why? Because you have 2 hydroxides. So if this is the total concentration, without doing detailed calculation, you know you will need half of this to figure out the molarity of the solution. Okay, but I'm going to write it out for you. So you have 3.3 times 10 to the negative 4 molar hydroxide ions, and this is of course in 1 liter, but then in 1 mole of magnesium hydroxide you have 2 moles of hydroxide. So really that's what you're trying to do. Okay, it's just divided by 2, so that's 1.7 times 10 to the negative 4 molar. Okay, that is your final answer for this problem. So the other way that I want to show you that you can do, and I don't have the answers here, I'm just going to set it up for you and you can do it yourself. So, or let me see, 1 second. Okay, so I did the calculations and here are the answers. So second way to do this is go ahead and use the pH, which is 10.52, and calculate the hydronium ion concentration, okay, in this one by taking the inverse log of 10.52, and so then you will get 3.02 times 10 to the negative 11 of this one. And then what you would do is, since this is the hydronium ion concentration, you would use Kw, which is the 1 times 10 to the negative 14 to calculate the hydroxide ion concentration. So the hydroxide ion concentration then is 1 times 10 to the negative 14 divided by 3.02 times 10 to the negative 11, and you'll get the same answer, 3.3 times 10 to the negative 4 molar, okay, as this is going to be your hydroxide ion concentration. So then once you have this, you still have to divide this by 2 in order to get this answer, okay. So that is your hydroxide ion concentration. So you can do it either way. If you find this one easier, you go ahead and do that one. If you find this one easier, you do this one, whichever.